In this question, there's a car that a child is playing with, and the child wants to launch it using a spring, and it'll travel along the horizontal surface. So let's place our origin here, meaning the horizontal surface is our origin. And let's do this by conservation of energy. So we look at this and say, well, are we moving initially? And the answer will be no, so there's no kinetic energy. We're located at the origin, so that'll mean we have no gravitational potential energy, and we're not above the origin at all. Is there a spring attached? Yes, there is this time, so we do have elastic potential energy. And then we look, is there any force pulling, tugging on this? And we say, no, there is nothing pulling, tugging on this at all. So elastic potential energy is the left side of the equation, and there's no work done. Next one will be on the right side. This car will now be moving, so there will be kinetic energy involved. And we're still on the horizontal surface. We've not gone above our origin, therefore no gravitational potential energy. And the spring will be completely relaxed, so no elastic potential energy left. Okay, and we look at this. It says ignore any friction force, so there will be no thermal energy. So our equation is elastic potential energy equals kinetic energy. Okay, so our equation would then be 1/2 kx squared equals 1/2 mv squared. K, of course, is our K constant, the spring constant. X is going to be the distance the spring is either stretched or compressed. Now let's figure that out. Let's see. When the spring is compressed, it has a length of 0.1 meters, but when it's completely relaxed, it has a length of 0.6 meters. So to determine our X, it's just the difference between those two. So 0.60 minus 0.10 equals 0.50 meters. So the X displacement of the spring is 0.50 meters. Now let's plug in. We have 1/2 the K constant, which is 500. We multiply that by 0.50 squared equals 1/2 the mass, which is 1.8 times the velocity squared. And solving for velocity, we get 8.3 meters per second. And that means the velocity of the car just after the spring is relaxed.